I hope you have done your exam well, all the exams, I hope so. Still now I'm not able to see the mark, so we will see. I already told them we have completed 4 units, purely theory portion. Maybe in our syllabus we have one is see here, it is 3 is to 0 is to 0, it's a fully theory paper. Maybe sometimes they ask some problem in module 2 in the GATE exam, not in our regular syllabus. We don't have any problem at all. Maybe once I finish the syllabus, then I will take up a few problem in the lecture number 7 and 8. Otherwise, all other topics they will ask one word answer or 2-mark question. I mean, the GATE point of view, right? So, GATE point of view, you may have some 1 or 2 problems the unit number 2 that we will cover in the later part of our class. We will finish the syllabus first, then after that, I will spend some time. Right? Module number 5 is fault analysis. Fault analysis and protection system. Remember, there are 5 analyses are so much important in the power system, right? So please note down. First one is load flow analysis. First one is load flow analysis. Second one is fault analysis or short circuit analysis. Second one is short circuit analysis or fault analysis. Third one is security analysis. Third one is security analysis. Fourth one is reliability analysis. Fourth one is reliability analysis. Fifth one is contingency analysis. Fifth one is contingency analysis. I will tell what is first one is load flow analysis or power flow analysis. That means how much amount of power, real power as well as reactive power is needed to maintain the load. Right? So that is nothing but load flow analysis or power flow analysis. How much amount of real power? For example, in the electrical machines lab, we have some 10 machines, right? 10 induction machine. Right? In order to run the motor, how much amount of real power and reactive power is needed? We have to include the losses also. Including the losses, we have to do the analysis. That is nothing but power flow analysis. Okay. Second one is short circuit analysis or fault analysis. This analysis will tell about what kind of fault and where it occurs. So this analysis, the result outcome of this analysis is where the fault occurs, which is the location of the fault, maybe between Irutupallam to Karnia or maybe Boys Hostel to our main distribution center, or exactly it will tell about where the fault occurs. So location of the fault, then type of the fault. The third objective of doing this fault analysis is to design the protection circuit. To design the protection circuit. For example, in your home, you take your home, right? Outside you have a meter, there you will have a fuse carrier you have, right? Maximum current drawn by your home is maximum 5 ampere, right? So if you put 4 ampere fuse, right, every time if you switch on, fuse will blow off, right? So in order to design the protection circuit, I have to do some fault analysis. Therefore, during the fault, my circuit breaker will trip off, or maybe my isolator will isolate it from the system. Right? In order to design the protection circuit, I have to do the fault analysis. Third one is security analysis. Security analysis, once again, take the 59C bus. Right? The maximum capacity of the bus is 60 plus 2. Right? 60 plus 2, one is driver, one is conductor, 60 passenger we can take it, right? During the, already I have told about these things, maybe weekend the bus will be crowded. So maximum it will carry 90 passengers. That is maximum securely if I want to go to corridor to Gandhipuram. Mostly we can put it. Actually, in abroad countries and all, they won't allow standing at all. Is not at all allowed. Like only sitting. That's what we have to go for another bus, right? But here, India's we are following. We are not following this standard. We will put as much as possible inside the bus, right? 90 up to 90. Sometimes it will go, right? But if I keep on allowing the passenger inside, maybe 100 or 110, right? From Karunya to, instead of going to Karunya to Gandhipuram, it will fell down in the Irtipalam itself, right? So how much, that is called as security. How securely I can transfer the power from sending end to receiving end. So such analysis is security analysis. How much maximum I can put it? How much maximum I can send it to the transmission line? Right? So that is nothing but security analysis. Reliability analysis means how reliable my system is. For example, tomorrow 10 o'clock, I need a power. If you promise your customer the utilization center, utility center will, and nowadays we don't have any assurance that tomorrow I'm going to have the power or not. So I am not rely on the right now situation, right? So in order to give that assurance, how much I can predict or how much I have to generate today and how much I have to cut down the loads, unnecessary loads, so that I can preserve some power on particular day at particular time. You got my point? So that is nothing but reliability analysis. How reliable my system is. Right? That is called as a reliability analysis. Right? The last one is contingency analysis. Contingency analysis means during the emergency. During the emergency, unnecessary, I mean, unexpected flood or maybe huge thunder or maybe heavy rain, right? The transformer and other things have collapsed during the emergency, right? How my system is performing. So that is called as a contingency analysis. Right? So these are the 5 analyses a power system engineer must know about it. Okay. So in our case, we are not bothering about security analysis, reliability, contingency, that is out of syllabus. Just for an introduction, in order to know about those things, I have told all those things. For in our syllabus, we will have only fault analysis and protection system. Right? So outcome, what is the need of doing short circuit analysis and fault analysis? I already told that. In order to find out what kind of fault and where it occurs, and to design the protection circuit. These are the 3 objectives to do fault analysis. Right? So based on this introduction, just I'm getting to the syllabus. It's very these 4 topics: 26, 27, 28, 29. These 4 topics are very easy, very simple. Only one point you have to remember while I'm teaching. I will tell about all those things. Right? So first 2 part is a little bit easy. Then second part of the syllabus is we have to draw a lot of diagrams. We will see one by one. Right? So we are going to see lecture number 25, 26, 27 today. Possible. We will complete. Right, please note down this one. Basically, power system is fault is classified into 2 major categories. One is open circuit fault. Second one is short circuit fault. Then open circuit fault is further classified into 1 conductor open, 2 conductor open, all the 3 conductors open. Then this short circuit is further classified into symmetrical fault and unsymmetrical fault. Then symmetrical fault classified into 3-phase short circuit, 3-phase to ground fault, and this. So I ask you to write down so that it will be stored in your mind. We will know kind of fault, but the category we may not know it. So this will tell about the faults are under which category. This will give a better clarity of the type of faults. request all of you please note down this tree diagram or this classification diagram. It's must. Major classification of the fault, major two classification, open circuit fault, short circuit fault. Then further classification. This is sub-classification. Okay. Okay. I will tell what is symmetrical component analysis. So as you know that we are doing some fault analysis, right? We are doing some fault analysis. I have told that in order to do fault, sorry, why, what is the need of doing fault analysis? First reason is to know what kind of fault. Second reason is to identify where the fault occurs. Third reason is to what can I say? To design the protection circuit. To design the protection circuit. For in order to meet out these three reasons, we have to do the fault analysis. Right? Okay, once fault occurs, right, the system becomes unbalanced. Once the fault occurs, for example, in machine slab, our generator or induction machine is running, maybe short circuit occurs between R phase and Y phase, or maybe R phase to ground, or all the three phases are short circuit. Some fault occurs in the machine slab or in the particular load. So immediately, what will happen? The system becomes unbalanced. Right? System becomes unbalanced. Unbalanced means, see here, unbalanced means